In this video, we're going to talk about calculating the pH during a strong acid, strong base titration. The particular problem that we're interested in solving involves the titration of 25 milliliters of 0.1 molar HCl, and we're titrating with 0.05 molar NaOH. And the question asks us to find the pH for volume of base added equal to 0, 10, 40, 50, and 100 milliliters. So let's, first things first, let's find out what the equivalence volume is. And for HCl and NaOH, we have a 1-to-1 molar ratio. So the reaction is going to be HCl plus NaOH, giving us NaCl and water. And for a 1-to-1 reaction, then, the molarity of the acid times the volume of the acid is going to be equal to the molarity of the base times the volume of the base at the equivalence point. So we can put in our numbers. We can have 0.1 times 25. Let's just keep our volume in milliliters. That has to equal 0.05 times VEQ. Solving then, we get VEQ is equal to 50 milliliters. Okay. So knowing the VEQ is pretty helpful for this kind of a problem. And it allows us to expect that at 0, 10, and at 40, anything where the base is less than that 50, that our pH is going to be determined by the excess HCl that's in our system. At the equivalence volume, at 50, the pH is going to be equal to 7. For a strong acid, strong base titration, the pH is always 7 at the equivalence point. And for a volume of base equal to 100 milliliters, we're going to have to consider excess NaOH. Okay, so let's do this. So let's think first about the volume of base equal to 0. So that is before the titration starts, and we're told that HCl is 0.1 molar, which means that H3O plus is also 0.1 molar. And from that we can infer then that the pH is equal to 1. If we have a volume of base equal to 10, then we have to do a little bit more work. So we want to calculate the excess HCl. Okay, so I'm going to do that in a reaction chart. So we'll have HCl plus NaOH giving us NaCl and water. And then I'm going to include the amounts, but this time I'm going to use millimoles, okay, instead of what we often do, which is use moles. So it's just going to be 1,000th of a regular mole. So in terms of millimoles, in our original sample of HCl, we had 2.5 millimoles. And we added to that 0.5 millimoles of NaOH. We don't have any NaCl, and we don't care about water. We allow the reaction to go, so we'll subtract off 0.5. We'll subtract off 0.5, that's the limiting reagent. we'll add 0.5. And then when it's all said and done, we'll have 2.0 millimoles of HCl, none of the NaOH, and 0.5 millimoles of the NaCl. Our pH then, our H3O plus concentration, is going to be equal to the concentration of HCl. So if we took this number of millimoles and divided it by the total volume, we could get the H3O plus concentration and the pH from that. So 2.0 millimoles divided by the total volume, which is 35 milliliters. And that leads to a concentration of 0.057 moles per liter and a pH of 1.24. At a volume of base equal to 40, then we're going to have the same general process, except at 40 we are adding 2.0 moles or millimoles of NaOH. So then our H3O plus concentration is going to be 2.5 minus 2 millimoles divided by 65 now. And that gives us a value of 7.7 times 10 to the minus 3. Let me put my units in there. And the pH then is 2.11. The last little bit, for a volume of base equal to 100. For a volume of base equal to 100, we are now adding 5 millimoles of NaOH. So for this, we're going to have excess OH or excess NaOH. So that excess NaOH is going to be the 5 millimoles that we added minus 2.5, which will react with the HCl. So that's the millimoles. We have to divide by the volume, 125 milliliters. And that gives us an OH concentration of 0.02 molar. And that leads to POH being equal to 1.70. And the pH then is 12.3. So we have 1.24, 2.11, 7, and 12.3 for the 4 pHs that we were supposed to determine. Thank you.